Okay, so this should be the final part of the mechanical build for the Kyosho Inferno 10E electric conversion. And then after this, I really just have to paint and mount the body, which is hopefully no big deal. So I'm going to go over some of a few details first, which I actually covered in a previous video, but I made some updates to. So I've been going back and forth about what kinds of universals I wanted to use on this car, either the 62.5mm long Optima type universals like these, for instance, or the Jazz Rider aluminum 62.5mm universals for the Kyosho Optima, or the standard Kyosho universals that are, say for the RB6, that are 65.5mm. I did try going to the 65.5mm to try to allow me to move these diff out drives in a little bit, but really the dog bone length on those is too long, because even if you move this little cup here inwards, the actual spine or whatever that extends out from the diff that this dog bone cup has to mount onto, or sorry, that the diff outdrive cup has to mount onto, that's still at a fixed position. So if the dog bone's too long, it's going to run into that. So really, the 62.5mm dog bone length is exactly what you should use. So on the front, what I have is for the actual diff outdrive cup, I mount it all the way in. I don't have any shims or anything pushing that out. And then I use the 62.5mm dog bone. On the inside here of the wheel axle, I use a 2mm aluminum wheel axle spacer. And then on the outside here, I don't use any spacers or anything between the drive pin and the outer bearing, and I have an 8mm wide wheel hex. Okay, and I use this 8mm wide wheel hex with modern Kyosho laser wheels, and this gets me to about the same width as the rear width on this car, with 6mm wide wheel hexes and modern Kyosho laser rear wheels. Okay, that's about as the best I can do in terms of equalizing the front and rear width. So in the back here, the diff outdrive cup here is mounted onto the little axle or spine or whatever you want to call it that comes out from the diff, with a little 1.5mm, sorry, this is a 2mm plastic spacer. These come on a lot of Kyosho parts trees, and they're just the right size to fit in here and space out this little cup between the bearing and the cup itself, and that pushes it out just enough so that with this dog bone length and no spacers on the inside here, I still get enough capture between the dog bone pin and the diff outdrive cup. So at full droop for the front and rear, I shouldn't have any issues with the dog bone popping out of the diff outdrive cup. Sorry, this phone's not really focusing. Here we go. And then on the outside here, between the drive pin and the outer bearing, I have 4 0.3mm spacers. Kyosho makes a little set that has 0.1, 0.2, and 0.3mm spacers. You could probably get them from Tamiya also. So I have 4 of those, so 1.2mm total between the outer bearing and the drive pin, with a 6mm wheel hex, and that's what gets me all set up with the rear. Another change I made is on the front shocks. Initially, I had mounted the front shocks with the actual bottom of the shock inside this hole on the arm, which is what you would normally do on a Kyosho laser. But if you look at how this hole is positioned and how the shock tower is positioned and how much I have to push this out in order to make sure that the shock collar doesn't ride up against the shock tower as the suspension is compressing, basically this shock ended up being mounted a little bit too far inwards, and it wasn't a really straight angle. So to straighten up the angle as much as possible, I just moved the bottom of the shock out to the front of the front arm here, and you just use a longer screw to get to, to actually mount the screw into the inside of the arm. Okay, so the new stuff has to do with some changes to the chassis and the upper deck and so forth. So to mount the speed control, because there's not a whole lot of space here to mount the electronics, it's a pretty narrow chassis. I have to mount it in the rear. Even though there's space up front, if you mount a body on this, like for instance if I use Kyosho laser body and I cut it to fit, the body really tapers down at the front and there's not much space between the actual front of the body itself and the front of the chassis. So thin electronics like a receiver or maybe a transponder you could fit up here, but a speed control with a heatsink and maybe even a fan, it's too thick. So I have to move that to the back. And because I had cut the upper deck on the left side of the chassis in order to be able to fit the left side saddle pack in, I don't want to add material to this side in order to mount the speed control. But there is room on the other side of the chassis to kind of, push this rightward a bit to mount the speed control. So all I really did here is I cut a little Kydex plate that was long enough to fit the speed control and the power capacitor, and I just drilled 2 holes so that way these 2 holes that mount the upper deck onto the rear gearbox, they also mount this Kydex plate here, and this is nice and sturdy, it fits just fine. So that's the speed control. A little note about the speed control, by the way, if you're going to do this particular setup, specifically with the motor mounted on this side facing rearwards, then you're going to have a speed control that allows you to run reverse rotation. And that's different from having a speed control that can run in reverse. Okay, so reverse rotation means that when you apply forward throttle, it runs the engine in reverse at full power. Okay, this is important because in this car, as originally designed as a nitro car, the engine sat on this side. So on the rear side of the spur gear, but on the right side of the chassis. So when the engine was spinning forward, the car was going forward. If you mount an electric motor on the other side of the spur gear, but on the same side of the chassis, if the motor spins forward, the car will go backwards. And you can't flip the diffs, which is a trick you can play in most other cars, where instead of the diff bevel gear facing, say, this side of the chassis, you just flip it around so it faces the other side of the chassis. You can't do that here because the chassis has little cutouts. You can't see it on the front because it's covered by the bumper, but in the rear there's a cutout right here. And the reason for that is because the diff gear itself protrudes a little bit into the thickness of the chassis. So if you actually took that diff gear and rotated it to the other side, or flipped it to the other side, so that way with a forward powered speed control running the motor in forward rotation, the car would actually go forward instead of backwards. When you tighten the gearbox down with a flipped diff, this diff would actually bind against the chassis. So if you really wanted to, you can cut out a bigger hole here to allow you to flip the diffs on both the front and rear, but I want to maintain as much material here as possible, which means keeping the diff in the stock position, which means for this particular setup, having a speed control that can run in counterclockwise rotation. Okay? So you have to do a little bit of research to find, for say the particular brand that you like to run, to see which ones actually enable that. I like to run Turnigy speed controls because they're affordable and they're quite good and they're quite adjustable. The 120 amp speed control and the 60 amp speed control can run counterclockwise rotation. Their 80 amp speed control does not support counterclockwise rotation. Okay, for some reason. I don't quite understand why. Maybe because the 80 amp is part of a previous generation of circuit board design, but the 60 amp and the 120 amp are part of a newer design, and so they support counterclockwise rotation. So get the 120 amp for this, because the 60 amp isn't quite enough amperage to run a 13.5 or a 10.5 motor. Set it up to run counterclockwise, and then you should be good to go. For the motor itself, I'm running right now, for the time being, a 14-tooth pinion gear. I have 0 degrees mechanical timing on the motor itself, and I set the boost to add, I think, 30 or 35 degrees of dynamic timing, kicking it at somewhere around, I think, 5,000 to 6,000 RPM. I tested that out on the driveway a couple nights ago, and it seemed pretty good. Okay, so what else? The steering servo. This, as you can see, is a low-profile steering servo. It's actually a Turnigy Trackstar TS-D99X. It's a low-profile servo. It's about 100 ounces per, or 100 ounce inches of torque, give or take a bit, at 6 volts. and the response time is about 0.1 or 0.09 seconds. It's a very fast servo, and this is probably one of the few servos that I would run that's not a high-tech servo, especially considering how to get a low-profile servo from a more name brand that has these specifications would cost you a lot of money. This is only about $30 or so. It's pretty cheap, and it's very good. I used to run this in my Nix 91 when I used to have that car. It was very fast. It ran perfectly fine. So I put that in here, and basically I'm using RC10 servo mounts to mount the servo, because on the original build for the Inferno 10, it actually had two different types of upper decks, but generally they required the servo to be mounted onto the upper deck, kind of upside down. And I wanted to mount the servo on the lower deck here, again, to partly to reduce how much overhang I have, or space I have above the chassis. I also want to try to keep the center of gravity low. And as you can see, there's a little bit of the edge here that overhangs the chassis, but it's not too bad, and it's pretty tight fit. So with the servo, I have a servo saver here, with everything lined up just right. That servo saver comes, relatively close to the center drive shaft, but there's clearance there. It does work. It's also worth pointing out that you want to mount the servo with the servo gear facing to the front. If you mount it with the servo gear facing to the back, then that servo saver, or if you run a servo horn, is going to hit the center mount for the center spur gear, okay, or the center diff, really. So you want to mount it with the servo gear facing toward the front, and then get a linkage that's of the appropriate length to get you from the servo horn or the servo saver to the bell crank. For this bell crank, the way I have it set up, these two screws here on the top of the chassis are a little bit loose, and that's intentional, because if I really crank this down, it'll bind the steering rack. So I just loosen these just a little bit, and that allows everything to move freely. And it's just something to check every run to make sure that they don't completely back out. Hopefully it shouldn't be a problem. Let's see, what else I did, you may or may not have noticed, also take the anodizing off of the bottom, the lower deck. Okay, so this was previously a blue anodized chassis, but I guess the previous owner had used it a fair amount, and it was really spotty. Certain parts were worn out and certain parts weren't. So basically I took a power sander with like 60 grit or 80 grit sandpaper, and I sanded off as much of that anodizing as possible. And then after that, I took some Brillo pads or some Scotch-Brite pads, and just by hand I tried to smooth out the rest and to make it look more like a brushed aluminum for the time being here. So this looks very nice, by the way. I like how this looks. It's also more uniform with the upper deck, which was never anodized. It's just a straight up sort of aluminum look. You may want to use some chassis protective material to cover critical holes here, like the hole for the rear spur gear, the hole to the rear diff gear, hole to the center spur gear, some of these other holes where rocks can sort of get up and hit things. I may use a full length a protective sheet later on, or if I can figure out an under tray that can actually fit on this chassis, I'll try that. So far, the front part of the chassis here is a little bit too wide to fit an under tray for something like a Kyosho Laser ZXR or Kyosho Optima. Those chassis tended to get narrower towards the front. This one is a bit wider at the front, so I have to find a different under tray and see if it'll fit. So I haven't quite worked that out yet. That's part of the sort of mounting the body portion of this thing. Let's see, I think that's it. Those are the main things that I did since the last part of the build, and it's basically done. The electronics are mounted, everything's good to go. I test drove this thing. This thing drives really nice. I'm actually quite happy with it, with the particular starting setup I have. Again, granted, this is on the street, which is a very high grip surface, but it corners very sharp. It drives, it has instant throttle response because there's no slipper clutch and the center diff is locked. So the moment you hit the throttle, it just takes off, which is something, you know, that's probably okay for like a dirt surface, but on a high grip surface, you may not want that. It could really beat up the drivetrain. But I plan on running this on dirt anyway. So I'm really looking forward to racing this car. This is really nice. I'm really happy with how it turned out. So I think that's, oh, right, sorry, one more thing. So with this motor mount, the way it came originally is it had these two holes right here. And with the way that you have to kind of manually define holes to drill for the mounting screws on the bottom of the chassis, if you don't get it just right, then it can make it really hard to adjust the motor mount position for different spur gear sizes. So another thing you can do to help compensate for that is just to drill more holes around this plate here so that you can rotate the motor inwards or outwards a bit if you're using a different size spur gear. So that's, or sorry, pinion gear. So that's really all I did here. You just measure, you know, the distance between the holes on the top and bottom of the motor with a caliper, and then you just rotate from the bottom hole over to the side to define a new hole position toward the inside, draw that hole, and you're good to go. So that's what I did here, and that's how I can get this 14-tooth pinion to mesh well with this spur gear. Everything spins freely. I have noticed that since I started building the diffs and sealing them, if you go back in my video history, I talk about how to seal these gear diffs. The oil has started to leak out a little bit. So after many, many months, you will start to see some oil seepage out of the gear diffs, even if you seal them up using the method that I mentioned previously. But still not too bad. You know, these still feel like they have some viscosity in them. So, you know, maybe before the Vintage Nationals, I might take this apart and rebuild the diffs just to be on the safe side. But so far, so good. And this car is pretty damn awesome, I gotta say. I'm really happy with it. So that's it for now, and thanks for watching.